Find the value or values of c that satisfy Rolle's theorem for the function f of x is equal to the cosine of 5/10 times x, or you could say 1/2 times x in the parentheses, within the interval from pi to 3 pi. Well, first we have to determine if this function is differentiable, or if it satisfies the conditions of Rolle's theorem. One of them is f of x continuous. The second one is f of x differentiable. And the third condition is f of pi, or in our case our a value, equal to the function evaluated at our b value, which is 3 pi. Well, first, is it continuous? Yes, it is. It's a cosine curve. Is it differentiable? Yes, it is, because there are no cusps, corners, or vertical tangents. Now we have to see if the function evaluated at our endpoints are indeed equal. So we are going to have cosine, and then because I'm dealing with trigonometry, I'm going to convert this decimal into a fraction. So I have 5/10 is equal to 1/2 times pi, and then is it going to be equal to 1/2 times 3 pi when we evaluate it. So we'll have the cosine of pi over 2, is that equal to should have written cosine here earlier, cosine of 3 pi over 2. Well, cosine of pi over 2 is 0, and the cosine of 3 pi over 2 is also 0. So yes, all three of the conditions of Rolle's theorem are met. So now let's work through and use Rolle's theorem. And Rolle's theorem says that f prime of c is going to be equal to 0. So let's take the derivative, put it in terms of c. So the derivative of cosine is negative sine. We're going to keep the angle in the parentheses, and I'm going to write it in terms of c and as a fraction. And then I'm going to take the derivative of the angle by the chain rule, and the derivative of c over 2 is 1/2. So we can rewrite f prime of c as negative 1/2 times the sine of c over 2. And the question is, where will this be equal to 0? Well, the coefficient of negative 1/2 doesn't really have anything to do with it. It's going to be, where is the sine of c over 2 going to be equal to 0? So we have to think of where the sine curve is equal to 0. Well, the sine curve can be equal to 0 when the angle is equal to 0, where the angle, or c over 2, is equal to pi, and potentially where it's equal to 2 pi, and we can continue and do 3 pi, 4 pi if we need to. So let's cross multiply and determine our c values here. C would be equal to 0 in this case, c would be equal to 2 pi in this case, and c would be equal to 4 pi in this case. Now let's look at our interval where we're concerned about our function. 0 doesn't fall within this interval, so we can cross that out. 2 pi definitely is, so that's a solution, or a c value. 4 pi is also outside of this interval, and if we kept going and set it equal to 3 pi, we would get another value that's outside of the interval. So the only c value that works within the given interval is c is equal to 2 pi, or Roman numeral 3 only, or answer choice A.